Hi friends, this is Naveen from AKN Sprint Education. Welcome to our YouTube channel. The topic that we are going to look today is the most important 8 mark questions from physical science. Coming to the topmost important 8 mark question is, write the precautions to be taken in the experiment to show air and water are essential for rusting iron article, and also write the experimental procedure. This is the most important question as I am expecting this year. So the first one is, what are the precautions to be taken in the experiment? Placing of clean iron nails in test tubes. Second one, iron nails must be completely immersed in water. Coming to third point, in test tube B, distilled water must be used so as to make it oxygen free. These are the precautions to be taken. So coming to aim of this experiment, to find out the condition under which corrosion occurs. As the materials required, we need 3 test tubes: test tube A, test tube B, test tube C, as it is given in the diagram. Iron nails, you take 10 to 12 iron nails and 3 cocks and anhydrous calcium chloride. Coming to procedure, take 3 test tubes and label them as A, B and C. Then place 2 to 3 iron nails in each of the test tube. Add some water in test tube A. Add some boiled water and 1 ml of oil in test tube B. Add some anhydrous calcium chloride in the test tube C. Then cork all the test tubes. Here, the oil present in test tube B will float on water and it does not allow air to get dissolved in water. Anhydrous calcium chloride present in test tube C absorb the moisture from air. Keep test tubes aside for few days, then it can be observed that iron nails in test tube A get rusted as they are exposed to both air and water. Right? Iron nails in test tube B do not rust as they are exposed to only water, and iron nails in test tube C also do not rust as they are exposed to only to dry air. So only in test tube A that iron nails going to be rusted, whereas in test tube B and test tube C they do not rust because test tube B is only exposed to water, but whereas in test tube C they only exposed to air. So from this we can come to one conclusion that it can be concluded that air and water are essential for condition for corrosion. What is the essential condition for the corrosion? It can be concluded that air and water are essential for condition for the corrosion. So this question, which is the most important question as I am expecting this year for 8 mark question. Okay children. Coming to second question, write the factors that influence ionization energy and explain any 3 of them. Ionization energy of an element depends on following factors. What are the factors that influence ionization energy? Coming to 1, nuclear charge. Second one, screening effect, or also we call it as shielding effect. The third one is penetration power of the orbitals. So what are the 3 factors? Nuclear charge, screening effect or shielding effect. Third one is penetration power of the orbitals. What do you mean by nuclear charge? Here, higher the nuclear charge, higher is the ionization energy. Example, chlorine atom has more ionization energy between sodium and chlorine. Right? Now coming to second one, screening effect or shielding effect. The decrease in nuclear attraction on the valence electrons due to the presence of inner electrons is called as screening effect. It is also known as shielding effect. ionization energy is less if screening effect is more. Between lithium and cesium, the element cesium has less ionization energy because more inner cells. The third one is penetration power of the orbitals. Orbitals of same main shell have distinct penetration power towards the nucleus. That is, more the penetration power, more is the ionization energy. For example, 4s is greater than, 4p is greater than, 4d is greater than 4f. I mean, in this 4f electron can be removed easily than 4s. Between the elements beryllium and boron. Boron has less ionization energy due to less penetration power of 2p on comparison with 2s. Okay. One more important question, that is, describe the silent features of modern periodic table. The main features of modern periodic table, there are 18 vertical columns known as grooves and 7 horizontal rows known as periods in the modern periodic table. Second points, elements in the modern periodic tables are classified based on electron arrangement which are replicated regularly. The elements in the modern periodic table are arranged in grooves and periods based on the electronic configuration of the atoms of elements. Physical and chemical properties of elements are related to their electronic configuration, particularly the outer shell configuration. Coming to fifth point, the elements in a groove must possess same physical properties and there should be regular gradation in their physical properties from top to bottom. Thus, they have same electronic configurations. Based on the entry of outermost electrons of an element into orbital, elements are classified into S, P, D and F blocks. Across the table, that is from left to right in any period, the atomic number of elements increased by 1 unit between any two successive elements. Thus, the electronic configuration of valence cell of any element in a given period is not same. As a result, elements along period possesses various chemical properties with regular gradation in their physical properties from left to right. Right? This was also the most important question, children. The next expected important 8-mark question is, write postulates and limitations of Bose-Hydrogen atomic model. According to Niels Bohr, electrons in an atom occupy stationary orbits of fixed energy at different distance from the nucleus. Whenever an electron is in excited state, that is a jump from lower energy level to higher energy level, the energy is absorbed. Similarly, when the electron is not moved to any of the lower energy levels from higher energy levels, the excess energy is emitted out. In any atom, energy of electrons is quantified. I mean, the electrons have only certain specific energy values, E1, E2, E3 and so on. So what are the limitations of Bose-Hydrogen atomic model? It could not explain Stark effect and Zeeman effect, and also does not account for splitting of line spectra of hydrogen atom into finer lines. Those are the limitations of Bose-Hydrogen atomic model. Okay, so you can write easily, children, which is the most important question. And also one of the important question that they are going to asking, that is Hund's rule. How does the Hund's rule helps in writing electronic configuration of an atom? Explain with a suitable example. What is the Hund's rule? As per Hund's rule, the pairing of electrons must happens only after filling available degenerated orbitals with 1 electron each. Thus, Hund's rules is used when the number of electrons to be filled are more than 1. For example, carbon, atomic number of carbon is 6 and electronic configuration is 1s2, 2s2, 2p3. Actually, 2p2, this is not 2p3, as 2p degenerated orbitals are px, py, pz. Electronic configuration of carbon is 1s2, 2s2, 2p2. Here in 2p orbital, there are 3 generated orbitals, that is 2px, 2py, 2pz. As the pairing happen only after filling 3 generated orbitals with 1 electrons each. The 6th electron occupies the next p orbital, py, not px orbital. Hence, the 2 electrons in p orbitals have same spin. They are shown as parallel spins. Right? This is the most important question. Nowadays, mostly they are asking Hund's rule only. The next expected 8-mark question is, write the required material and experiment procedure for the experiment. Hydrochloric acid react with zinc pieces and liberate hydrogen. Which is the most important question? Aim of the experiment is to show that acids produce hydrogen gas when they react with metals. The materials required are test tube, delivery tube, glass through, candle, soap water, dilute hydrochloric acid, zinc granules and cork. Coming to procedure, set the apparatus as shown in the figure. Take about 10 ml of HCl acid in a test tube and add a few zinc granules to it. Formation of gas bubbles can be observed on the surface of zinc granules. Pass the gas which is formed in the test tube through the soap solution taken in a trough by using delivery tube. Bring a burning candle near to the gas filled bubble in soap water. The gas present in soap bubble burn with a pop-off sound and puts off burning candle. The pop-off sound indicates that hydrogen gas is liberated. The chemical reaction for the above activity is when acids react with metal like zinc, you will get salt and hydrogen. So metal in the sense here zinc, acid is hydrochloric acid. When zinc react with hydrochloric acid, you will get salt, that is zinc chloride and hydrogen gas. From this activity, it can be concluded that hydrogen gas is liberated when acids react with metals. So what are the precautions you must take in? Hydrogen gas reacts explosively with oxygen present in air. Thus all the air inside the apparatus must be displaced before collecting the hydrogen gas. While testing the presence of hydrogen gas with candle, it is advised to wear fireproof gloves in order to avoid any accidents. These are the precautions we must take in when we are doing this experiment. So this is also the most important question, children. Coming to next question, explain the behavior of light rays in any four situations of their incident on a convex lens. Coming to first point, ray passing along the principal axis. See here, any ray passing along the principal axis remains undeviated as shown in the figure 1. If a ray of light passing through the principal axis, it is undeviated. Coming to second one, ray passing through optic center. Any ray passing through the optic center remains undeviated. Coming to third one, ray passing parallel to the principal axis. If a ray of light passing parallel to the principal axis, after refraction, it converges at the focus as shown in the figure C. Now ray passing through the focus. If a ray of light passing through the focus will take a path parallel to the principal axis. So after refraction as shown in the figure D. See children, first point is passing through the principal axis, along the principal axis. Second one passing through optic center. Third one is parallel to the principal axis, and the fourth point is passing through the focus. These are the behavior of light rays in four situations on their incidence on convex lens. Diagrams are important. Go through the question carefully, children. So students, these are the important questions. 8 mark questions they may ask this year. So children, go through this video carefully. Even you try to write in a piece of paper so that you can easily write in your answer sheet. So don't forget to hit subscribe button, children. Like it and share it with your friends. Thank you.